right, we're continuing with Chapter 5, Section 5, solving right triangles. How many angles does a right triangle have?
3.
How many sides?
3.
So when we're solving a right triangle, we're solving for all 3 sides and all 3 angles. Yes, I saw your fingers go out there, Adam. 3 fit. Now, what I'd like you guys to do on your paper, if you would please, is I want you to create a little space for your final answer. All right? Now, my suggestion, wherever you see angle C, always put 90 degrees. We have lowercase a, lowercase b, lowercase c. So this is going to be your final answer. Now, every single one of these problems, they've given us certain pieces of information. Okay? In this particular triangle, they said lowercase a was 9 units. They said capital B is 49 degrees, which makes it very easy to find capital A, because the 49 degrees and whatever number we put in here have to add up to 90, because we already have 90 degrees. These are, by the way, A and B will always be complementary. Okay? How many degrees, Adam? 41. That's correct. Because 41 degrees plus 49 degrees is 90 degrees. And 90 plus 90 gets you to a total of 180. Because when I say triangle, you say?
180.
Triangle.
180.
Triangle.
180.
We have a cheerleader here. All right. Now, basically, all I have to do is find B and C. Okay, sorry. You dance more than you cheer. All right, I apologize. Okay? All right. Now, guys, this right triangle right here, can everybody see that this right here is your 90-degree angle? Now, if you don't like that right triangle because it just looks kind of funny to you, you can create your own triangle if you want to. All right? You could call this C. You could call this A, and you could call this B if you wanted to. All right? So it doesn't matter how you create it. All right? Just as long as you create a triangle that is a right triangle, you can label all the sides and the angles. So let's use this. Right now, what are we saying A is equal to? 41 degrees. Angle B is 49 degrees. C is our hypotenuse. We'll label it the hypotenuse. Now, if we're going to find lowercase b or lowercase c, we have to go from a perspective. So we have to make a choice. Which angle do you guys want to go from? You guys want to go from the 41-degree angle? Okay. Or do you guys want to go from the 49-degree angle? All right, you want to go from 49? We'll go from 49. Okay? So what I'm going to do, if you've chosen the 49-degree angle, Caitlin, I'm going to draw an arrow going across. That's pretty important because that right there is going to help us label this lowercase b as our opposite side, which means our lowercase a is our adjacent side. Ooh. Put it right here next to lowercase a, put 9. Yeah, because they gave us A. A is equal to 9. All right, so which side do you want to find? Adam, do you want to find B? You want to find C? You got to find one of the two. Which one do you want? B. All right, I'm going to put a little box around B, which means this is the one that I'm trying to find. This is the one that I actually have. So if I'm trying to find this one, and this is the one I have an opposite and I have an adjacent. Which one of these trig ratios deals with opposite and adjacent? Is it so? Say it again. Tangent! Yay! Because we need our what? We need our opposite side, and we have our adjacent side, and this OA part is the opposite and adjacent. What does OH stand for? Opposite hypotenuse. What does AH stand for? Adjacent hypotenuse. So, okay. Do you see why we draw the arrow? We draw the arrow to label our opposite side. Then we figure out, what do I have? What do I need? What do we have? We have the 9. What do we need? The opposite side. So here we go. Ready? You're going to write the tangent, everybody, of what angle? The tangent of the 49-degree angle equals my opposite side, which is lowercase b, over my adjacent side, which is 9. And just place this over a 1. Now, King, you actually did a good job of choosing the 49-degree angle, because where is the variable end up being? It ends up being up in the numerator. And whenever you guys cross multiply, when the variable's in the numerator, look what happens. What's b times 1? b times 1 is b. And 9 times the tangent of 49 is going to give us 10.35. So that approximately is equal to a 10.4. That's the length of our side for b. So right here, where it says b, I'm going to erase the little box. I'm going to put 10.4. Because it said round to the nearest 10. Round to the nearest 10, if necessary. So it was necessary for us to round to the nearest 10. Now, everybody, once you've solved for it, you don't have to keep using trig. Because you know that a squared plus b squared equals c squared. Now, let me explain to you what I want you to do. I don't actually want you to use the 10.4 when you square it. I want you to use the whole thing. So, here's what I want you to do. When you typed in 9, tangent of 49, and you got that 10.35, what was our a value? Our a value is 9, right? 9 squared plus, I want you to go up and grab the whole thing, and then I want you to square the whole thing and press enter. And then what are we going to do with this answer? Take the square root, right? Take the square root. And what does that give us? That gives us 13 point what? 13.7. Which means our final answer for C, our hypotenuse, is 13.7. Now, what if you would have used the 10.4 instead of the whole approximate value? What would have happened? How did a 9 squared plus 10.4 squared, and then taking the square root of this, what you would have got? 13.75. What's going to happen if I say round that to the nearest 10? What's that going to end up becoming?
14.
No.
Right.
13.8. So if you use this one, which is the more accurate answer, you get 13.7. If you round it and use your approximated answer instead of the long answer you got to begin with, are these both approximations? Yes, these are technically both approximations. But which is the more accurate approximate value? The first one. So that's why I want you to square the first one, not the second one. Okay? Because it could make a difference. If you would have put 13.8, I would have marked it wrong. Don't round until the very, very, very end. Okay? Use all of your numbers as you possibly can until the very end, then round. Every single one of these problems, everybody. Make your own triangle. A, B, and C, what do all these angles add up to? 180, and then you're going to find the lengths of the three sides. Sometimes you're going to use trigonometry, sometimes you're going to use the Pythagorean theorem. But you have to solve the triangle, so find all of the parts. And that's it. How about this? Before we move on, I'll hope you guys set up number 12. All right, I'm going to zoom in on number 12. Right here. You're going to draw a triangle. Not going to solve the problem, it's going to help you set it up. Okay? Now it says angle A. I'm going to put angle A right here. I'm going to call that a 16-degree angle. All right, this is going to be lowercase a. Here's lowercase b. Here's lowercase c. There's a 14. I'm going to say angle A, angle B, angle C. Lowercase a, lowercase b, lowercase c. Angle A is 16 degrees. Angle C has to be 90. So what does angle B have to be? Has to be what? 74 degrees. Look at 74 degrees. So 74 degree angle, we have a 16 degree angle, and we have a side of 14 for the hypotenuse. So basically all we got to do is find A or, not A or, A and B. Once you find A, you can find B. Adam, which perspective would you like to go from? Would you like to go from angle B or angle A? Doesn't matter. Go from B? Alright, I'm going to go from angle B. I'm going to highlight angle B right here. Since Adam chose angle B, where am I going to draw the arrow from? Angle B. He chose it. Draw an arrow going across. Which means lowercase b is my opposite side, and lowercase a ends up being my adjacent side. Adam, which one do you want to find? A or B? Doesn't matter. B? Alright, find B. If you want to find B, here's what you have. That's my opposite side. That's my hypotenuse. Opposite hypotenuse. Sine. Yes, sine is opposite and hypotenuse. Okay? So Cato. Alright, so here we go. Sine is the opposite over the hypotenuse. So right, the sine of 74 degrees equals my opposite side over my hypotenuse. By the way, if you wanted to find the lowercase a, that's what? The adjacent over the hypotenuse. If you want to find lowercase a, you could say the cosine of 74 degrees equals my adjacent side, lowercase a, over my hypotenuse. By the way, this ratio right here, everybody, this ratio right here will give you lowercase a. This ratio right here, this proportion, will give you lowercase b. This proportion will give you lowercase a. I guarantee if you cross multiply, you'll get your two answers. 14 cosine 74. And b will equal 14 times the sine of 74. That'll give you the approximate value of a. That will give you the approximate value of b. And that's all I have to say.